We from the team of Step Up Bengal again welcome all of you in our next discussion of a question from CSIR Net Math June 2016, and that is 4.75 marks question. June 2023 exam is very near. All of you perhaps are looking at your preparation, last moment preparation. We can say that this type of problem will help you tremendously. In this channel, Step Up Bengal, you will get UG2 higher level maths. So, especially applied maths. So, before starting the video, we from the team request all of you to follow the channel, and if you like it, then please share among maximum number of students so that they can get tremendous benefit on applied math. Here in this channel, basically we discuss applied maths topics. So again, this is applied math topic. In the previous few lectures of classical mechanics, we are just forming finally Lagrange equation and its varieties types. Those of you are new to this particular platform, please revisit our channel and go through the playlist of classical mechanics. Here you can have a separate playlist of classical mechanics where you can learn ideas about the syllabus of classical mechanics in CSIR Net Math oblique set exams of different states. Now, the Lagrange equation we all know is ddt of del L by del Qi dot minus del L by del Qi equal to 0. But the beauty of this question from CSIR is that here they have given a particular force Q which is not arising from potential. All of you are requested to mark this portion. Very important clue is given here. Not arising from potential. When the force is not arising from potential, the equation of motion will be Qi, not 0 in the right hand side. This is important. Now question comes, what are Qi's? I in general will run from 1, 2 up to n. Qi will be those forces not arising from potential, say as frictional force. This is a particular force which does not arise from potential. Here we need not discuss details about the forces which are not arising from potential, because to solve the problem we need to know this form of Lagrangian equation. This is important. This is the type of Lagrange equation which are extremely important to solve any problems where the force is not arising from potential. Now in this given problem, only the direction of x-axis is considered. So I here is 1 and Qi is obviously x. So let us write down this equation in our form. That means according to the demand of the question, this is ddt of del L by del x dot minus del L by del x equal to Q. This is our equation number 1. So first of all, we would like to calculate all the terms in the left hand side and just put the values here and get the result. Now see, let us how that can be done. The beauty of this question lies in the calculation technique which we will discuss in details. So don't be fearful at all that we cannot solve this or difficulty may arise, etc. Since L is given to be 1 by 12 into x dot to the power 4 plus half into x dot square minus x square. So first of all, let us calculate del L by del x dot. All you have to do is to just go through the expressions one by one and according to demand calculate. So del L by del x dot, what will be that? 4 by 12 x dot to the power cube plus half into x into the derivative of this quantity, that means 2x dot, and this will obviously be 0. And at the same time we should calculate this also, del L by del x. What will be that? That will be half x dot square minus 2x. From here x is only in this term and in this term, so we have to need this. Then come to the next step. ddt is outside del L by del x dot, so we do that. ddt of del L by del x dot, what will be that? That will be, this is our 1/3, so 1/3 into 3x dot cube into x double dot, because here we are not going through partial differentiation, here it is total differentiation, so x double dot should be and must be there, plus x double dot, because these two will be cancelled and we should go to the derivative of x dot, that means product form. So first one will be fixed, the derivative of x dot will be x double dot, plus next x dot will be fixed, derivative of x dot will be x dot again, so this will ultimately be x dot square. Now all the results are ready, we should put that here. What will be then the total result? X dot square into x double dot plus x double dot plus x dot square minus half into x dot square plus 2x. Why this plus sign? Let us see. Here it is in minus sign, minus 2x, but in the equation there is only already a minus sign, so that will be reversed and this sign will be negative. This sign will be negative and this sign will be changed, so it will be negative and it will be positive. The remaining term will be as calculated, so just we have put that here. So ultimately what we are getting here, in the right hand side we have x dot square x double dot, because q is given. Look at this quantity, q is given, so q is given. See how nice the formation of q is, that this quantity and this quantity is eliminated, so we only have these three terms. So it will be x double dot plus half into x dot square plus 2x equal to 0. Let us make it very simpler as x double dot plus, take this x in the denominator, so half into x dot square by x plus 2 equal to 0. This is our equation number 2. Up to this there is nothing difficult, but the beauty of this question, as I have already said you, lies in the fact that from this step we need special type of calculation. Apparently it looks like a non-linear ordinary differential equation, but with suitable substitution, this is important, with suitable substitution we can transform it into linear differential equation, LDE, whose general form was just in our UG program as dy by dx into px plus px into y equal to qx, and its integrating factor is always e to the power integral px dx. This is the part as we have already very familiar, we are all familiar with this result, no doubt about this. Now let us look at this beauty. We should just substitute x dot square as u. Take u as, or rather we should substitute x dot square by u, and therefore very easily x dot will be root u. Now in our equation there is x double dot, so let us calculate that. X double dot will be, the derivative of this quantity will be 1 by 2 root u, into du by dt. Let us write this as 1 by 2 root u into, we should call it du by dx into dx by dt by chain rule of derivative. Now look at the fact, dx dt is x dot is already root u, so this root u and this quantity will be cancelled. So we will finally have this as half into du dx. Clear? So this quantity is done. Let us put all these here. What will be then the equation? Half into du dx plus half into u by x plus 2 equal to 0 implies du by dx plus 1 by x into u equal to minus 4. Is it not LDE, or rather first degree LDE? Yes. Then what will be the integrating factor? Integrating factor will be e to the power integral 1 by x dx. That will be e to the power log x, and that will be x ultimately. So the solution of this equation will be u into that integrating factor x equal to integral over minus 4x dx plus c1. This c1 we have to calculate from the given condition. These two conditions will help us. Let us see now how. Next, what is u? U is x dot square, so x dot square into x is equal to, that will be minus 4 into x square by 2 plus c1. These two will be cancelled with 4 as minus 2. So we will ultimately have x dot square equal to minus 2x square plus c1. Now put the conditions here. X0 is 1. This is the beauty of the problem. This 0 refers to the value of time t. So x dot should be and must be used properly, because x dot is also given as initial condition. Look at this, x dot at time t equal to 0, that is also 1. So we should put all this. What is the value of x? This is 1. What will be the value of x dot 0? This is also 1. So 1 square equal to minus 2 into, this is 1 square plus c1, implies c1 equal to, these 2 will be taken to the left hand side and c1 will be obviously 3. So we have arrived at x dot square equal to, let us put this c1 first, then that will be 3 minus 2x square. Here we also have this x, so take that x in the right hand side as x dot square equal to 3 by x minus 2x. So what will be our x dot? That is the question. X dot is equal to root over 3 by x minus 2x. From the question it is very much evident. Look at the options. They have asked about x dot at different values of x. So ultimately in this solution process we should have a relation between x dot relation type. We should and must establish this relation. Unless we establish this particular relation we cannot solve it. So this will be that relation. That relation is done. Now the problem is very much clear to all of you perhaps. Now you can easily solve all this. Let us go to the options one by one. First, option 1. For some, the value of x dot will be, they are saying the value of x dot will be some non-zero finite value at x equal to 0. Let us put at x equal to 0. So x dot is equal to 3 by 0 minus 2 into 0. This quantity will go to infinity, so that is not finite. Clear? So obviously 1 is wrong. Next, come to option 2. It is 1, so x dot equal to, at x equal to half, let us put x equal to half. What will be that? 3 into half will be reversed, so that will be 2 minus 2 into half. This will be cancelled, so root over 5. Is it root over 5? Sorry, 3. This is not true. 3 into 2 x, they have told you about x is equal to 1. Sorry, let us just, don't mind, just simple mistake. We should correct that in a minute. In the option 2 we have, x equal, at x equal to 1 x dot should be 1. Let us put x equal to 1. Root over 3 by 1 minus 2 into 1. That will be root over 3 minus 2, that is 1. So obviously 2 is correct. Then come to option 3. X dot will be, they are saying root 5 at x equal to half. Just put that here. Root over 3 into half will be reversed as 2 minus 2 into half. This will be cancelled. So we will finally have root 5. Is it root 5? Yes. So this is also correct. Now come to the last option 4. They are saying it as 0 at root over 3 by 2. So just put all the results here. 3 into x. X is root over 3 by 2. So that will be reversed to be root over 2 by 3 minus 2 into root over 3 by 2. So that will ultimately be, this 3 will be cancelled with this root 3 and we will have root 3 into root 2, that means root 6, minus here we also have root 2 into root 3, that means root 6. So this will obviously be 0. So this is also correct option. Actually, this particular type of formation we can see in the book of Herbert Goldstein. That is a very important book to cover all the topics of CSIR. In the library of physics students, that means the library not in the traditional way, the library just where we go often and just enjoy different ideas from books. Here the library refers to the own library system. That means at home, for each and every physics students, this particular book Classical Mechanics by Herbert Goldstein is there. In that book, in the exercise, this type of L is given, but they are in that particular question, this x square is replaced as vx and CSIR just, and this q is missing in that exercise. This q is missing. This CSIR authority has just put in this particular q to make it more difficult, more and more difficult, I would say, so that each and every student may feel difficulty to just solve this problem. But if we go to each and every details of equations, specifically Lagrange equations, and in different forms, we have already discussed in the previous lectures. See all those lectures of classical mechanics where you can easily find all the forms of Lagrange equations. And once you have gone through those results, then it will not at all be difficult, and people from math background will easily solve this particular result. There is no doubt that this substitution is critical to solve the problem. Actually, one of our team members has helped me tremendously to make this suitable substitution and ultimately solve the question. So I would just like to give special thanks to him. Whenever we do teamwork, then many important and difficult problems may be solved, obviously solved with 90% success rate. So in this video we stop here. In the next segment we will see different topics from classical mechanics. So good night and bye.